But there is another spacecraft even further away. Voyager 1 is now the most distant man-made object in the solar system. At some 9 billion miles from Earth, Voyager 1 is about to leave our solar system, destined to wander the stars of the Milky Way, perhaps forever. If Voyager should encounter any alien beings, it too carries a greeting. A gold-plated phonographic record attached to the side of the probe contains images, natural sounds, and music from Earth.
Hello from the children of planet Earth.
Symbolic images explain how to play the record and where it comes from. If we were to wait until some alien finds one of the space probes and replies, it could take millions of years. But why are the scientists so positive that there are other intelligent beings in the galaxy? It's a simple case of numbers, very large numbers. It's estimated there are at least 70,000 million stars in the universe. The big question is how many of those could be home to advanced life. Back in 1961, the father of SETI science, Frank Drake, came up with an equation for calculating how many alien civilizations there could be in our own galaxy able to contact us. Drake asked how many stars are there capable of supporting planets with intelligent life, and then how many planets would have radio technology, and how long do the civilizations with such technology last.
One of the problems, of course, with the Drake equation is that we can't actually solve it, if you will. I mean, we don't know the values of many of the terms. And if there's even one term in that equation that you really don't know at all, then the end result is an answer that you don't know at all.
Nevertheless, many scientists believe that even when the most conservative numbers are punched into the equation, you still come out with many intelligent civilizations in our galaxy alone. But that raises a question, one that was highlighted as long ago as 1950 by physicist Enrico Fermi. In what became known as Fermi's paradox, he asked, where is everybody? If our galaxy is so crowded, why haven't we heard from anyone? For an answer, we traveled to Denver, Colorado, to meet planetary scientist David Grinspoon. He's an advisor to NASA on space exploration strategy and has studied the search for alien life for 15 years.
Are we alone? No. We're not alone. I'm sure there are other species and other life and even, I would say, other civilizations out there. It's not something I have direct evidence for, but I feel like I have a lot of indirect evidence in terms of everything I understand about how we got to be here on Earth and everything I understand about what seems to be going on in the rest of the universe.
Grinspoon has come up with what he calls the seedling hypothesis. His analogy is that the universe is like a forest full of mature trees and exotic creatures. We Earthlings are just tiny seedlings. Perhaps someday we'll grow into something interesting, but right now we're not even noticeable. It may be humbling, but we might just not be important enough.
Maybe they're just not that interested in us, in a universe with perhaps all kinds of creatures and civilizations. We're very new to the scene. We haven't necessarily accomplished that much or done that much to distinguish us for somebody who's really been around a long time.
But there may be a better answer to Fermi's paradox: the sheer size of space. Even for a smarter-than-average alien, the laws of physics are a major stumbling block to interstellar travel. A century ago, Einstein figured out that faster-than-speed-of-light travel was impossible. To break the speed-of-light barrier requires an infinite amount of energy. And even if alien spacecraft could approach the speed of light, scientists suggest that for every pound a spacecraft weighed, 1 billion pounds of fuel would be needed. And traveling around the galaxy at anything less than the speed of light would take millions and millions of years. But maybe aliens will be content to travel around at more modest speeds. Perhaps they live longer than us. Even on Earth, there are life forms that survive far longer than us. The Californian redwood trees can live for 2,000 years.
The fallacy is in thinking that other advanced species would care that something couldn't be done in a human lifetime. What if you let the trip take 1,000 years or 10,000 years? I think there's a chauvinism, a temporal chauvinism, where if something can't be done in 100 years or a couple hundred years, then it's impossible.
But perhaps we suffer from environmental chauvinism as well, finding it hard to imagine how life could survive in strange conditions, and yet some of the strangest environments can be found here on Earth. Next, Naked Science descends into one of the deepest caves in the U.S. and comes face to face with an organism that lives in total darkness and survives by eating rocks. We've learned that scientists believe advanced life could exist elsewhere in the universe. So far, we have no proof. But scientists are making startling new discoveries. They're finding microscopic life forms in the most inhospitable places, right here on Earth. If life can flourish in the most extreme conditions here, the possibility of it taking hold elsewhere in the galaxy seems much more likely. But even if we do find evidence of microbial life infinitely less intelligent than us, why should we care? Microbes can't tell us the secrets of the universe. They can't talk to us. Planetary scientist David Grinspoon thinks any such discovery would be of huge significance.
If we find microbial life anywhere in our own solar system, that implies a very fertile universe. It implies that making life is something that planets do, and that implies that there are intelligent species out there in great number, some of whom will want to talk to us.
Meet astrobiologist Penny Boston. She spends her life in some of the darkest, most hostile places on Earth. She's looking for extremophiles, microbes that can thrive in places that would kill most other creatures.
What we're doing in extreme environments on Earth is really trying to write a field guide to microorganisms on planets that we've never been, for organisms that we don't even know exist yet.
Carlsbad Caverns, New Mexico. These are some of the deepest caves in America. What could possibly exist down here in zero sunlight? The lights may be off, but somebody's in.
Sure nothing's growing up on them.
Penny Boston has found microbes that nourish themselves by literally chomping their way through solid rock. Rock eaters.
These are the organisms that manage to liberate small quantities of material from the rock itself. That is, they chemically react to these. And during that reaction, they get energy from that process. And that's the energy that provides the foundation of their life. And so they then use that energy, just as we eat food at the dinner table. And so their ability to survive in an environment that is essentially food-free is one of the things that we are focusing on the most intensely.
And it's not just in deep cave systems that these extremophile microbes are thriving. This is Mono Lake in California. It may look beautiful, but the salt levels are 3 times greater than in seawater. It's poisonous to humans, but it's teeming with microbial life. And extremophiles can survive extreme cold, too. This is the Fox Tunnel in Alaska, an extremely cold environment. But amazingly, even here, there are microorganisms in the permafrost that can stay frozen for millions of years. And they are still alive. By warming them up, scientists have been able to revive these dormant organisms.
As much as we can stretch our imaginations in every conceivable direction of the limits of life, that makes us better and better prepared to recognize life when we see it wherever we find it elsewhere, in our solar system and ultimately beyond.
So what we need is an interplanetary field trip to search for microbial life. Next, we travel to the largest moon of Saturn, Titan. It's the only moon in the solar system with an atmosphere. Titan has an orange haze surrounding it. This haze could be concealing carbon-rich lakes and oceans, and possibly life.
2, 1.